Can we make a car that is powered only by wind energy, which can go faster than the wind? This is the question that we'll attempt to answer, and you'll be surprised and fascinated by what's coming up in this video. On this channel, Synergy Files, we aim to inspire budding engineers and technicians for a better, more sustainable world. Subscribe today to learn engineering through interesting and innovative ways. So we come back to the question, can a car that is only powered by wind energy be made to go faster than the blowing wind speed? The answer is yes. While it would be fascinating for many to learn that it can be done, and it has been done, but the more interesting bit is how it's done. Before we begin to answer the question, let's lay down ground rules for some physics and engineering that are going to be our tools in examining this proposition. Firstly, we should understand that perpetual motion machines do not exist. In other words, energy for running any machine should come from some source. A machine cannot run from nothing. Secondly, it must be understood that there will always be some losses between the energy input of the system and the energy output. There will always be a portion of energy that will be lost and cannot be recovered, and therefore even the most well-designed machines are less than 100% efficient. If these fundamental concepts are missing from our understanding, then we can make grave errors in judgment and come up with ideas that are scientifically absurd and impossible. You might have heard people suggesting that we should stick wind turbines on a car, so when the vehicle goes on a highway, the turbines would spin fast and recover a lot of energy. However, people fail to take into account the extra amount of power from the car engine that would be required to push that turbine at highway speeds. This extra amount of power would be much higher than what the turbines will be able to generate. Imagine just a flagpole on the back of a cyclist, and you will be able to appreciate the extra drag force that the cyclist needs to overcome. Having said that, the idea of wind turbines on a vehicle is not entirely absurd, meaning we can use them if they are foldable or retractable and can be deployed while the car is parked. Please note that on average cars are parked for over 90% of their lifetime. When the car needs to be driven, then the turbine has to be folded away so that the vehicle maintains a low profile in front of the oncoming wind. Through this system, wind energy can be harnessed while the car is parked and can be fed to the car's battery pack. Now, the system that we have just mentioned, that is car with a foldable wind turbine, is one which will work if there is the provision to store energy inside the battery pack, which means that there is a disconnect between the points when the energy is being captured and when it's being utilized. The system we are going to discuss now is the one that doesn't have any provision for energy storage, and it runs off wind energy available at any given instance. In other words, we will be looking at land yachts. It is surprising that people generally think that wind-powered land vehicles cannot go faster than the speed of the prevailing wind. One can also feel the same for sea vessels that rely on sails. This is despite the fact that high-speed sailboats have already been designed that go faster than the wind. We have achieved speeds of 78 miles per hour or over 120 kilometers per hour when the wind speed was only 29 miles per hour. The reason why these vessels can attain speeds of higher than the source that pushes them is because they rely on lift force rather than push force. We normally tend to imagine wind-powered watercrafts as one with masts and square sails. Yes, any such vessel is reliant on pushing force of the wind, and it cannot go faster than the wind speed. This is because the push effect will diminish when the vessel's speed reaches close to the wind speed. However, as mentioned earlier, high-performance wind vessels don't rely on push force but rely on lift force. And the lift force is dependent upon not the absolute wind speed but the apparent wind speed. As the vehicle speeds up, it intercepts the oncoming wind at higher speed. This makes the apparent speed higher, which consequently increases the lift force. The increasing lift force accelerates the vessel further. But bear in mind there is a counter force that also rises with the increasing vessel speed, and that is the drag force. The drag force also rises sharply depending upon the profile of the vessel, and when it becomes equal to the lift force, the vessel would not accelerate anymore. An example of lift force based land vessel is the Greenbird. It broke the land speed record for the fastest wind powered vehicle in 2009 by reaching speeds of 126.1 miles per hour, or about 202.9 kilometers per hour. It uses a rigid vertical wing instead of a conventional sail. Okay, with the understanding we have developed so far, we can now take another step forward. It's time to introduce wind powered vehicle that can go faster than the wind speed and uses a propeller instead of a sail or a rigid wing. Note that we have used the term propeller, not a turbine. Interestingly, this has already been demonstrated in 2010, where the land yacht called Blackbird was clocked being almost 3 times the speed of prevailing wind. A speed of 27.7 miles per hour or 44.6 kilometers per hour was achieved in 10 miles per hour wind. This vehicle was sponsored by Google and developed by Rick Cavallaro and John Borton. A lot of people are still not convinced how this propeller-based vehicle could go faster than the wind, and you find physicists on both sides of the debate. The acronym DWFTW is often used to describe this condition, which stands for downwind faster than wind. Even though after the demonstration many were convinced that it works, but were at loss to explain the mechanism behind this faster than wind vehicle. Here is an explanation that I think will help to settle this. Imagine a horizontal conveyor belt or a travelator moving alongside a fixed vertical wall. Now imagine a wheelchair placed on this conveyor belt. Obviously, the wheelchair will move with the same speed as that of the conveyor belt. Now imagine that there is a dynamo or an electrical generator that is attached to the wheelchair. This dynamo, if pushed against the stationary wall, will produce electricity. Now, if that electricity is fed to a motor connected to the wheelchair, then the wheelchair would theoretically move faster than the conveyor belt, provided the energy generated by the dynamo is more than the friction losses. The increase of speed of the wheelchair will speed up the dynamo further and more electricity will be generated. This creates a positive feedback loop. The wheelchair would keep on speeding till the frictional forces between the dynamo and the wall and the wheelchair wheels and the travelator catch up with the energy generated by the dynamo. Please note that the energy for moving the wheelchair is coming from the travelator or the conveyor belt. It is the presence of a stationary medium, that is the wall, which allows us to tap additional kinetic energy from the travelator or conveyor belt even when the wheelchair is moving. For a land yacht, the stationary medium is the ground with respect to air. For a high-speed sailboat, the stationary medium is the seawater. As long as there is a difference in speed between the two, that is the stationary medium and the moving wind, additional kinetic energy can be tapped for the moving vehicle because there's always something to push against. This wouldn't be possible to do in, let's say, an aircraft traveling in the jet stream because there's nothing to push against. Coming back to the Blackbird land yacht, the wheels are connected to the propeller such that their motion drives the propeller. When such a vehicle is exposed to wind, the wind will apply a push force on the vehicle because of its profile. The forward motion of the vehicle will turn the wheels, which in turn drives the propeller. The propeller turn creates a negative pressure in front and a positive pressure in its wake. This pushes the vehicle further forward, thus creating a positive feedback loop. The energy for the car is coming from the wind and its interplay with the static ground. The vehicle will keep on accelerating till the drag on it and the rolling resistance becomes equal to the propelling force. And with this, hopefully the conundrum of DWFTW proposition would now be settled. Yes, it can be done. As far as practicality goes, the propeller-based vehicle can only move along in the direction of prevailing wind, be it upstream or downstream. So yes, it is not a technology that will change the way we use transportation. However, this technology can be coupled with other technologies to create sustainable and autonomous modes of transport. Take for example, wind-powered railway service in areas where wind direction remains almost fixed. So we hope you would have learned something from the video. If you did, please do hit the like button and subscribe to the channel. Thank you for your attention.